After much fighting with YouTube and technology at large, I found that, well, let's see, YouTube basically ate my video for this example, so I'm just going to go ahead and redo it. This is example 7-11, all the way back from chapter 7, section 3, where we were talking about confidence intervals, and here we're talking about confidence interval for a proportion P. So this was chapter 7, section 3, example 7-11. All right. So this is one where we're going to be finding the sample size that is necessary, the minimum sample size that is necessary in order to get our margin of error a certain size. So what do we usually want to do? We want to make our survey or whatever, our results, a confidence interval in this case, as accurate as possible. So we want to control this margin of error as much as we possibly can, get it as small as possible. So what we're going to be doing here is setting the margin of error, and from that figuring out what n has to be. So what I normally do is, I can never remember more than one formula. It's okay. As long as you can remember one formula, then you don't have to know all of the different versions of it. You can solve for it algebraically. So here, how do we compute the margin of error? This is all I need to remember, because if I need to solve for a different variable, I'll just solve this one equation for that different variable. So here I'm writing down from the best of my ability, that says p hat times q hat all divided by n. So there we have our formula for the margin of error. And like I've been saying, I'm just going to algebraically go ahead and put in the steps and solve this for n in terms of e. So that way we can just plug in whatever we have for e, and we'll be able to get out what n is equal to. All right? So algebraically rearranging this formula, we're going to be solving it for n. So the first step was to divide both sides by z subscript alpha over 2. And so on the left-hand side we end up with e divided by z subscript alpha over 2. And on the right-hand side, that is equal to the square root of the whole thing, p hat times q hat, all over n. So then, let's do the next step. Okay, as you can see here, the next step is to go ahead and square both sides of the equation. And so the result of that is that squaring this side cancels out our square root. Well, that's the best that I can draw it. So we'll reformulate and look at what we have in the next line, and then determine what the next step is going to be. Okay, at first I thought about switching the left-hand side and the right-hand side, but then I realized, oh look, okay, I'm solving for n and it's in the denominator, so we'll multiply both sides by n, and what that will end up doing is bringing it up and over here. It will get canceled out when we multiply by n on the other side. Okay, and here, just cleaning this up, we obtain n times e divided by z subscript alpha over 2, that whole quantity squared, is equal to p hat times q hat on the right-hand side. And so we're going to divide by E over Z subscript alpha over 2, whole thing squared. Oh. I wrote those parentheses in a weird order, I suppose. Let's see. Okay. Now, so that will yield N is equal to P hat times Q hat times Z subscript alpha over 2, all divided by E, and that whole thing squared. All right, so one thing that you might notice here is instead of dividing by E over Z subscript alpha over 2 and writing it and indicating it as a division, instead, what did I do? I multiplied by the exact reciprocal of it. So notice Z subscript alpha over 2 divided by E is the reciprocal of E divided by Z subscript alpha over 2. Now, all of that was just so that I didn't have to just memorize this, okay? And, you know, I give you an aid for memorization. I say, you know, anytime you're going to use, anytime you're going to use a formula, anytime you're going to use a formula, write it down from memory. So, you know, we could have noticed the elements of this problem and identified them at first and just recited this formula here from memory. Okay? But another technique that I like to employ is being able to do the algebra and derive a formula from one that I know that I didn't mess it up, okay? Or at least using that as a failsafe to sort of jolt my memory in case I'm suspicious that I might have memorized it wrong. I can kind of go back through the derivation of it and see, you know, if it is correct, because it should make logical sense algebraically speaking. All right, so that whole thing is going to be what we're going to be needing in this problem to find E when we are given N. No, I'm sorry, I said that exactly wrong. When we are trying to find N and they supply us with the margin of error E. Okay? So this whole time I've been saying that this is the type of problem that we're going to be doing. And I don't think we looked at example 7-11 yet. So let's get back to that task at hand. Now this one, I'm publishing this after I've already done example 7-12. And in that description, I said that was a redo of 7-11 and then YouTube 8, 7-11. So here, we're essentially just redoing the same problem as 7-12, except in this case we have a value that we can utilize for P hat. Okay. So here, let's go ahead and read the example. In 7-11, we're talking about landline phones. A researcher wishes to estimate with 95% confidence the proportion of people who did not have a landline phone. A previous study shows that 40% of those interviewed did not have a landline phone. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Okay, so hopefully you could see or you could tell what I was doing to break this problem down. We wanted 95% confidence, therefore 1 minus alpha is 0.95, therefore alpha is 0.05. They supplied us with a previous study, and so we're just going to go ahead and assume that that is close to the results that are going to be occurring in this study. We should be able to have a crude estimate, at least, for p hat. That's 0.4. Therefore, q hat is going to be 0.6. They said we wanted to be accurate to within 2%, so notice we are given the margin of error, and that is 0.02. And here they say find the minimum sample size. So remember, we always want to take as large of a sample size as we can, right? But we obviously can't take everything, so we want to come up with a reasonable lower bound, right? Say you got to do this much, but anything after that is just extra on top of it. Okay, so for alpha equals 0.05, we look up our z subscript alpha over 2, or remember this is one that is very frequently occurring, so we can just memorize essentially that it's 1.96. We'll go ahead and plug that into our formula here. N is equal to p hat times q hat times, what did we say? Z subscript alpha over 2, all divided by e, and that whole thing squared. So that's the form for the function, or sorry, for the formula. We're going to substitute in 1.96 in place of z subscript alpha over 2. We're going to go back to here and plug in 0.02 for E. And let's go with blue. All right, for Q hat is 0.6, and why not green for P hat is 0.4. So those are all of the elements of the computation that we're going to be doing. And we'll pause for calculator. And calculator says, drum roll, 2,304.96. I just wanted to write it fancy like that. But either way, we'll go ahead and round that up to 2,305 because, again, we're finding a sample size and we want the minimum, so we're not even going to say 2,304 because then somebody could give us that and that'd be too low. All right, and so we'll end it there.